Hello and welcome. I'm Lee Archinal from Cyborg Security, and I'm here to help you to get to know your logs. The purpose of these videos is to make you aware of and get you familiar with the information found in the endpoint logs within the Windows environment. In part 1, we covered process create events and how to conduct hunts based off of the information found in those event logs. In part 2, we're going to be doing the same thing, but this time with registry keys, so we'll be looking at different fields and different data, but the same concept. Alright, let's get going. Before we get started, I do want to recommend another video that I created titled Threat Hunt Deep Dive Episode 7, User Account Control Bypass via Registry Key Modification. Now, this video talks about a specific attack where a threat actor can modify a specific registry key to gain privilege escalation. Now, I would recommend watching this after we cover registry keys and what they do, so you have a better understanding of what they can do, what information is within, and how this can affect it. But it was a really fun episode. The user account control bypass topic is very interesting to me, so I would recommend going to watch it right after this, so you while it's fresh in your head. So, in case you missed part 1, I want to cover this again. What are the goals? What's this series about? So, I've been a SOC analyst for 4 or 5 years, and I've been threat hunting for about 3. And there's a lot of information out there, and these are some of the tricks of the trade that I've picked up along the way. And I just want to pass some bits of information that I can to the community, SOC, threat hunter, CTI, whoever you are. I'm just trying to share the knowledge so that next time you're in an engagement or next time you're trying to figure out what you should be doing, maybe you can look back and say, man, Cyborg really helped me out. And for our log list, today, these are the videos that will be coming up or have already been published. Part 1 was process create logs, where we covered Windows Event 4688 or Sysmon Event ID 1, which all deal with processes kicking off. We looked at command line arguments and elevation privileges, how to differentiate between an admin running something and a standard user. Also, we touched briefly on PowerShell logs and how, I'm not going to spoil it for you because I want you to go watch it, but how they log differently, and there's a specific log source for them to find certain things. So I'm going to leave it there. Hopefully you'll go back and watch part 1. Now, we're on registry key events, so we'll be looking at Windows Event IDs 4656 and 4657, and, we'll be looking at Sysmon Event IDs 12 and 13. Now, in the future, look forward to files being created and file create stream hash episode coming out. That's Sysmon Event ID 11 and 15. Some network connections, looking at Sysmon Event IDs or ID 3. The reason I'm not doing any proxy or firewall logs right now, because this is all focused around endpoint logs and what information you can find there. But if that's a requirement in the future, or that's something you would like to see, please submit comments below saying what you want to see in the future. Also, pipe names being created, which was Sysmon Event IDs 17 and 18, and RDP logs 131, 132, 140, and 148. Now, this is not the be-all, end-all list. Like I said, if you want to see something different or something covered a little more in depth, please let us know. We're here to help the community and pass along the knowledge. So what are registry keys? Let's take a look at what Microsoft says and how to technically define these things. So the registry is a system-defined database in which applications and system components store and retrieve configuration data. The data stored in the registry varies according to the version of Microsoft Windows. Applications use the registry API to retrieve, modify, or delete registry data. Now, it's pretty technical. There's actually a lot more to registry keys as well, but I'll break it down in a way that I understand it. So basically, registry keys control the configuration of the Windows machine. You can set things to kick off right away whenever you turn the machine on. You can confine restrictions within the registry keys by disabling some applications. But there are 4 main reasons that I'm going to talk about in this video of why registry keys will be modified. First, to harden the system, which is a legitimate reason. If you're killing applications or possibilities of applications running like RDP, if you shut that down in the registry, and it's going to take a lot more than just a UAC pop-up to run it. Also, you can weaken the machine through the registry key. Same thing for RDP. If you disable RDP within the registry, and then an attacker gains a foothold, and they enable it, they can now use RDP to gain access and persist through that compromised machine. 3, persistence. This could be legitimate or malicious depending on what it is. Now, a legitimate reason for persistence is if you have certain applications that need to be turned on or run on startup, you would put them in the run registry key. If it's malicious, a threat actor is dropping their malicious piece of malware within that same registry, where every time you reboot, the malicious application will reach out or it'll kick off, and who knows what that'll do. And exploitation. I mentioned the UAC bypass techniques. These modifying certain registry keys affect multiple executables and applications within the Windows environment. And this is a common technique we see, especially from ransomware. As I stated earlier, we'll be looking at 2 different log sources, so I wanted to show you examples from both. The first log source we'll be looking at is from Windows Event Log, and then we'll be looking at sysmon logs as well. But this is an example of event ID 4656, and the task category is registry and keywords audit success. So we can take a look at the fields that are provided. We see account name, domain, the security ID, but really we want to look at object name. This contains the path to the registry key that was audited or an operation was run on. Now, some fields that we can look for, like I said, the object name, this will show up in 4656 and 4657. The object value name, which is going to be the registry key itself, new value and old value, which contains the data with it for that registry key. Those only show up in 4657. And also the process name. This is the process that caused the registry key to be modified or enacted upon. Here's a very fuzzy example of a sysmon event log. This is event ID 13, which contains or is a set value type of event. So if a registry key has been modified, this will capture the data and the registry key that was modified. If we take a quick look at the fields, we see they're a little different, but we see image, which is the Windows System 32 reg.exe. So this is the process that caused the change. Target object, this contains our registry key path as well as the registry key name. The registry key name is actually at the very end here. So this whole thing is the registry path, and legal notice text is the registry key itself. Now the details, this will contain the information for that registry key as well as the user. Some things to look for: target object, details, image, user, and the process ID. Process ID is always something useful that we can use to pivot through our hunts with. Now, here's Windows Event Logs 4656 and 4657. I know I showed you 4656 earlier, but I want to put them side by side so you can really take a look at the different information that they provide. Once again, looking at 4656, we just have the object name. Now 4657, here's the object name. Here's the object value name, which is the legal notice. And then looking down here for the change information, we see the old value type, and then the new value type and the new value. So we can see that the only thing changed within this registry key were the numbers that you're supposed to call. And here are the sysmon event IDs 12 and 13 side by side. Taking a look at the very first thing at the top, we see 12 is registry object added or deleted. So that's how sysmon 12, or that's the information that sysmon 12 picks up on. and registry value set or a key modification is event ID 13. The big main differences here are the actions and as well as the target objects, the lack of details within event ID 12, and they're present in sysmon event ID 13. So different ways that a threat actor or just a insider threat can modify these registry keys. They can use command line modification. There's the regadd syntax where you can add registry keys, you can delete registry keys, and you can query them. So basically figuring out information about the registry keys that you want to look at, enumeration being a key motivation behind that. But the command would look like this: regadd HKLM, which stands for key local machine. The path is software, Microsoft Windows, current version run. That's that registry key I was talking about earlier, with the value being the key name, the /t being the type of key, and there's different types that we can look into later or on your own. I don't think I cover it, but it's specific for different things. And then the /d is the key's data. So how we saw that call a toll-free number, this is where that would land. The regadd command will work in both command prompt and PowerShell. You can use PowerShell commandlets and scripts. Now, I touched on this on part 1, but if you're looking for command line arguments and process create events, PowerShell commandlets and scripts have their own logging, which is the PowerShell script block logging, and that will be in event ID 4103 and 4104. But you can use the new item and the new item property and the set item property to modify the registry keys and add the same information as above, but in a different syntax. Also, executables or scripts that aren't PowerShell or command line can change the registry keys within a system. Also, you can use regedit, which is a tool in Windows, to manually look at the keys themselves and then modify it within that tool. You need admin privileges and it's a little noisier, but it's still a possibility. Some registry keys that we want to look at and focus on, they're really the threat actors use these and abuse these a lot. So the software Microsoft Windows current version run or run once path, these are those registry keys that contain executables that start up when your computer starts up. So the goal here is if the threat actor drops a executable on your machine that uses to call out to a C2 or beacon back to their machine and give them a reverse shell, they would want to put it in the current version run registry key location. That way, whenever you turn on, their executable calls out to their computer, and all of a sudden they have access to you again. So it's a pretty nifty way and scary way, but we know to look for maliciousness within this registry key location. Also, the system current control set services. This registry location provides information on the services that are currently running on your machine. Once again, a way to gain persistence is dropping or having a threat actor drop a malicious service on your machine that beacons out every minute or 2 minutes or 15 or whatever, just looking for data, basically telling the threat actor, hey, I'm still live, I'm still compromised, I'm waiting. Now there are also registry keys that are more specific, like the UAC bypass technique. These registry keys listed are some that can be abused and exploited to gain system level privileges. And once again, I talk about this in the Threat Hunt Deep Dive, so by all means, go check that out. Really appreciate it, and I'm sure you gain a lot of knowledge. All right, now that we're done with a quick overview, let's generate some traffic by completing some tasks. So the thing we're going to do is we're going to use command prompt and PowerShell commandlets. And the tasks we're going to complete are we're going to get calculator to pop on startup. So start thinking about where you think we're going to put that executable. We're going to change the default windows from light mode to dark mode. We're going to change the homepage of Google Chrome. Once again, remember, the registry holds the configurations of almost everything that is on that computer. So even changing the home pages of the Google Chrome browser, we can do that. And find the services that are within our environment within the registry. Like I said, a threat actor can compromise your box and start enumerating things. And one of the things they can look at are services that are running, because if they query the registry and they see that there is a Windows Defender service, they can either go into the registry key or registry if they have substantial enough privileges, and they could turn it off. So that's what we're going to do. We're going to look at services, and then we'll get on, or after the lab, we'll get on to the threat hunt. All right, let's go. Sorry to bring you back to the death by PowerPoint, but there's some things I wanted to cover that I forgot to. So we're going to be using a couple different tools here, and I wanted to cover that before we get into the lab portion and the threat hunt. But we'll be using a SIM, which is a Security Information and Event Manager. Basically, it is a centralized logging solution. It collects a bunch of logs, and then you can filter them through them based on different values, terms, or event IDs. Regedit.exe, which is the Microsoft built-in tool to physically look at the registry keys. Or I guess not physically, but in a nice tree form. We got command prompt and PowerShell, which are the two shells that we'll be using to modify registry keys. We have Event Viewer, which is the collection of logs that we generate and from all different sources. And I'll show you that later. And we'll be using Process Monitor. Procmon is part of the Microsoft Syst internal suite, and it's a nice tool to use when you're detonating malware and you don't know what it's going to do. But you can take a snapshot, or sorry, not a snapshot. You can look at the registry keys being changed in real time. So if you don't have a SIM in your lab, or if you don't have great log collections, you can still use Procmon to monitor the registry keys. And when we go to the hunt, what are we going to be looking for? Things we're going to pivot off of, the registry key itself, values being added, parent processes. We're going to be looking at different event IDs, and some specific things within the registry key details itself. All right, let's actually get to the lab this time. Welcome to the lab. Before we get our hands dirty, I want to give you a quick overview of what we'll be working with. On screen, I have all my notes in Notepad++. We have the tools we're going to cover. We have the tasks we're going to complete, and the registry key locations and commands that we're going to issue. Hopefully, by doing this, if you're following along in your own lab, you can recreate this as we go, pause the video if needed, and then get the same results, or see if you're getting the same results. And if not, make some modifications as needed. But so the tools we're going to use, like I said earlier, Event Viewer, Command Prompt, PowerShell, Regedit, and Process Monitor. And we have our tasks listed, which we'll get to as we go step by step. But first, I want to show you where to find these. So if you go to the Start menu, first thing you can just type in is Event Viewer. We're going to pull it up as admin. And it's going to take take a while, especially because it's loading a bunch of information, and all the logs that were even started once this computer started are all generating and being stored in there, so it may take some time to open up. So here it is in the background. We see our log locations, and the Windows logs, the security logs are what we're going to be looking at specifically when looking for registry key modifications. Also, because we'll be covering Sysmon, if you install it on your own computer, you're going to find that under the Applications and Services logs. Click that, and once again, it's going to take some time because it is loading a ton of logs from different log sources the first time you open it. So it might take some time. While that's going, I'm going to show you command prompts real quick. So you can always type it in your search bar if needed. As you could probably tell on my computer, it's pasted everywhere. It's in the taskbar. It's on the start menu. But if all else fails, come down to the start menu, click start, and type in command prompt. Now, because we're modifying registry keys, I'll always be running it as administrator. Okay, we're going to close that out. All right, so our event viewer is starting to populate. Back to sysmon logs. So applications and service logs. Click on Microsoft, Windows, and then we come all the way down to the S section. And here we go, sysmon, operational. This is where we will be finding the logs that we generated. Okay, we can close that out real quick for now. PowerShell, once again, type in your search bar, run as admin. That'll pop up, and that's how we'll be working with that. The registry editor, this one, I think, oh no, they changed it. So I used to have to type in regedit the whole way for it to pop up. I don't know if that was a security thing or that was just my computer, not sure. But as you notice, I just typed in REGE. Okay, so regedit. What this is, it is the visual layout of how the registry keys are stored. So there's different hives. There's classes root, current user, local machine, users, and current config. They all contain configuration information that do different things whenever it comes to the group policy or any other ways that the computer is set up. The main two that we'll be working on today are current user and local machine. But if you open the arrows and just start looking around, you can see under software we have a bunch of different software, and you can keep coming down these, and each of these pieces of software have their own registry keys that can be modified and changed to either harden or to restrict capabilities, to enable capabilities, or even just change the way it looks. Now, process monitor. This, I think it's found as procmon. This is actually found in the Microsoft Sysinternal Suite. So if you don't have it on your computer, you'll have to go and download that by itself. Or not by itself. You can download the suite, or you can download, you download the suite, unzip it, and then you can download whatever you need, and use whatever you need. But something about Process Monitor that you need to be aware of is whenever you first open it up, it will start storing all the logs in what they call a backing file. So if you come down to the bottom, you can see that there is, right now it's showing over 250,000 events of over 500,000 events. And it's backed by virtual memory. That means all of this, or all these logs, and all these almost 750,000 logs are being stored in RAM. So what you need to do is stop the capture immediately, come over to File, and go to Backing Files. See, it says use virtual memory, and it's almost up to 6 megabytes. Or sorry, 6 kilobytes. So what we need to do is we need to change that to use file name. And all I'm going to do is click that, come up to desktop, and I'm going to create a new folder called procmon logs, and hit save. Hit OK. It says you changed will affect the next time you begin to capture a new log. Okay, so we're going to delete this. So now our memory is cleared. Then we can start, or we can hit this button to start capturing it again. And now we come down here, and it says showing all these logs, backed by and the location of the procmon logs. So that's important to know, because the first time I ever ran this, I didn't know that. And 5 minutes in, or 10 minutes, I can't remember, but I got the blue screen of death, and I started panicking because I was a new security guy, and I was like, oh man, I got malware. But it'll shut down your computer. Okay, so with that quick overview, let's move on to task 1. Okay, so for task 1, I'm going to demonstrate how to enable auditing on a registry key. Now, the reason this is important, because there's many times that I've read an Intel report and it's mentioned a registry key, and I came to the lab, I tried to recreate it, and I recreated it, ran it properly, I saw the changes, I saw the exploit happen. Then I went to the Splunk, our SIM, and I couldn't find a trace of it. So I went through and I made sure that all my spelling was correct. I tried it again. I dug into more research. Is my Windows version current enough to be exploited? Come to find out, I forgot to enable auditing on the registry key at hand. So that's important because if your keys aren't being audited, they won't show up in Event Viewer, which means if they're not showing up in Event Viewer, they will never be ingested by your SIM or EDR or centralized logging tool of choice. So first thing we got to do is come over and we got to open up regedit again. Run it as administrator because normally to do this you need administrative privileges. I know that's not always the case, but I'm going to get into the habit of doing it just because. So the one thing you don't want to do is come to the highest level hive, which would be one of these, and click permissions, advanced, auditing, and then add. If you do that, every registry key that falls in that hive will begin being audited. Registry keys are very, very noisy and will blow up your SIM or Event Viewer, or you'll miss it because there's so many logs. So you want to get as close to the key as possible that you can. So for example, if we look at our task 2 key, we're going to look at the local machine, software, Microsoft, Windows, current version, run key. So let's actually go there right now. Actually, it's neat. I'm going to show you. We can copy and paste and go straight there. Hit enter. Okay. So I'll blow this up for you guys. So on the left we have our tree, and we can follow all the way down to where we're at, which is the run. So like I said, if we only went to local machine, everything that you see falling under it will be audited. So we hit the software, we hit Microsoft, we hit Windows, and now we are at the run. Now, anything that's added here will be audited once we enable this. So I'm going to right click on run, come down to permissions, I'm going to hit advanced, I'm going to go to auditing, and as you can see we have full access already, but to do this you would hit add, select a principal. In this case we do everyone, it finds it. Normally you'd hit OK, then we click full control and hit OK. And now your registry key is being audited. So once you see some auditing entries down here, you're good to go. To test that, you can open up Event Viewer. Give that some time again. We're going to close that out. Come over to Windows Logs, and we're going to run a quick command right now in command prompt that's going to query that key that we just looked at. So I'm going to run reg query hklm software Microsoft / Windows. Where's my notepad? Current version run. Oop. And put in quotes and hit enter. And you can see we have some keys under there. To find that, we come over to Event Viewer. We're going to focus on the 4656, which is a, no, not 4565, 4656. Hit OK, and see if we can find it in the log. So we're going to refresh this first. Scroll down. Current version. See if we can find it within the first logs. Nope, maybe we can just find it. All right, there it is. Okay, so we got a 4656. A handle to an object was requested. The task category is under registry, and that's the registry key that we queried on to get some information on. So we see that our auditing has been enabled. So let's move on to task number 2. So for task 2, we want to configure our machine so that calculator opens up once we reboot or restart. So the way to do that is we're going to get the calculator executable, which is calc.exe, and we're going to place it in the current version run registry, where we're also going to have to add a registry key name. So what we're going to do is we're going to open up a registry editor real quick, run as admin. And here we still have the location for the current version run registry key. Now what's going to happen is through command prompt, our commands are going to add a registry key down here. The type will be the registry string. And now I'm not going to go into depth with the different types of registry keys or data, but you can look that up on Microsoft because it gets pretty in-depth, and that seems like a whole other topic that I could cover later on. But what we're going to see is the data is going to be the location of the calculator executable. So if we come over to Notepad, this is going to be the command that we're going to run. So we're going to do regadd the registry key location. /v is the value of the registry key name, which is we're going to call calcpop. The type is the string, and the data will be C Windows System32 calc.exe, or the location of the registry key name, or no, sorry, the calculator executable. So I'm going to see if this works. I'm going to copy this, go over to command prompt and run it as admin. And can I just paste this in? No. All right, so regadd HKLM for the location, software. Did I spell that right? Yeah. Microsoft Windows current version /run, and that's where we stop. And that's where, or if we keep adding things on, we'll actually create more registry folders underneath run, which isn't what we want to do. So we're going to go /v, and we're going to call it calcpop /t reg string, and do a /d, and we're going to extend this so it doesn't get all messy. Windows System 32 calc, and you can hit tab to complete this. I did it a little too early. Calc.exe, and then to top it all off, a /f, which is it will force this to be successful, or run anyways. If it errors out, it won't populate the registry, but we won't get an error. So I hit enter. The operation completed successfully. Come back over to registry editor. It's not there, but if we come up to view, refresh, or if you're using a Windows box that you're actually running on, you can hit F5, and now we have calcpop. And like I said, we confirm that it is a string and that the location is the Windows System 32 directory. Now all we have to do is restart, and let's see if this happens. All right, so I edited out the whole section where it just restarted and I had to re-enter my password, but if we did this correctly, calculator should be popping up pretty soon because we added it to the run registry key. We restarted. Let's see what happens. There it is. Sweet. So we know we're successful because not only did we not only did we add the registry key, we confirmed it in regedit, and we restarted the computer and the calculator started. That's awesome. All right, on to task 3. before we start task 3, I want to cover something that I forgot to mention in task 2. The power behind putting an executable in the current version run key location is persistence. If this goes unnoticed by any security or administrator out there, whatever goes there stays there until it's deleted. So if a threat actor puts a key in there and has a malicious executable, that is going to stick there and stay there and run every time you boot up. And that's how, like, small organizations without a big security footprint, they can become infected and stay infected because there's maliciousness within the configuration of the computer itself. So I just want to mention that before we moved on. So for task 3, all we're going to do is we're going to change a styling convention within the machine. We're going to change dark mode or the default style of Windows to either dark mode, or we're going to check to see if it already is and then change it to light mode. So here is the registry key location. So once again, we're going to pop open regedit. I should probably just leave this open from now on. But we're going to copy and paste this again. So this one is in the current user registry hive. So we need to come all the way here, H key, current user, then copy and paste. Got to remove that HKCU because that is the abbreviation for H key current user. Hit enter, and we got apps use light theme, which is a 1. So what that tells me is 1 is on and that it is using the apps light theme. So we can test that by going to settings. And as you can see, the settings window is all white. Now, by changing it to dark mode, this should become black. So let's go back to our notes. Okay, so we're going to use PowerShell this time, and we're going to use PowerShell commandlets to show you the different ways of being able to do this. So let's do a quick copy and paste. Now, using commandlets like this, it takes some time. And you can do it step by step, but you have to create nope, okay, we're not doing that again. So new item, we're going to give it the path to look at, HKCU :/software, and PowerShell is nice and friendly when using the new item, and you can hit tab for the registry keys. Microsoft Windows, current version themes, and themes, and personalize. I'm sorry, no, not new item. The item exists already. So because I'm really sorry about that. Because the item exists already, we're going to use set item property, because new item is to create a new registry key in the location that you're looking at. Set item property is to change the property of that registry key. So because we're actually modifying an existing registry key that's there, we're going to use set item property. So current version, themes, personalize. Let's move that over and stretch it out. We'll shrink it down too so that we can see what we're doing. Notepad. There we go. The name. So here we gotta use the TAC name instead of the /v. Is apps use light theme. And the value, to determine what the value is going to be, we come back to regedit. So apps use light theme. It's a D word, so it's a 32-bit value, which is just a 1. So what we're going to do in PowerShell, we're going to add a 0. And then the good old TAC force, which once again will force it to make it happen. I don't know if you saw that, but the PowerShell bar got dark. Come back to the registry, view, refresh it. We see apps use light theme. Once again, the data has changed from a 1 to a 0. And then we can come here To confirm it, hit settings, and the window's black. So once again, a small configuration change, but I hope what I'm demonstrating here is making it sink in that almost everything is in the registry. So if you can't find command line arguments that make the changes, you can look in the registry and find the changes that are being made because it's on the configuration level. All right, so we completed task 3. Now let's move on to task 4. For task 4, our goal is to change the Google Chrome home page and set it to something or a website of our choosing. So, spoiler alert, it might be something I'm very fond of and familiar with. So we're going to check out the location of where to modify this, and that will be under the local machine software policies registry location. So we're going to scroll over back to regedit. We're going to go to local machine, drop down. It's going to be, what do we say, software and policies. And the first thing I notice is that there is no Google policies. So we're going to have to create one. Also, we're going to have to create a Chrome key as well. Because if we look at the policies, we see Microsoft, which is like a big umbrella of things. And then that has a registry of each different application on it, like Windows Defender, Microsoft Edge, and so on. So we're going to have to create 2 folders down. So to do that through PowerShell, I'll pull our notes up as well. We're going to have to create new item because this registry key does not exist already. I'm going to do software policies, and we're going to name it Google, and we're going to force the issue. Okay. It tells us that the registry key Google has been named or created. Once again, we're going to always trust but validate. So refresh, and we see the Google. All right, so the next step would be to create a Chrome registry key. So we're going to come back up, type in Google, and we can tab over now because it exists. Hit name. We're going to name this one Chrome. And once again, we're going to force the issue. It tells us it was successful. It shows us trust but validate or trust plus verify. Sorry, Reagan. And here we are. So looking at, there are no registry keys by default. So now we need to create, or we need to set an item there. And that's what this set item property is going to be used for. So I'm going to run a set item property. Path will be HKLM :software. Oh, not HLKM, HKLM. That's why the tab wasn't working. Policies, Google, Chrome. We're going to name this home page location. Value is going to be cyborgsecurity.com and force it. Before we do this, we're going to actually open up Chrome and see what the settings are now. If I remember correctly, I configured this so that there is no home page. So if we hit home page, it won't do anything. Did I type in force? All right, I typed in force. All right, come on, Chrome. Okay. Oh, it's dark by default as well. That's neat. Okay, if we click on the home page, it's the main search bar, and we can see if we come over to settings and type or click appearance. Where are we at? Go over to the appearance. We have the show home button open or enabled, but we need to enter a custom web address. So we're going to come over here and execute our PowerShell command, hit enter. Okay, no errors. Come over to registry editor, There we go. All right, the home page has been set. Now let's see if that translates. If we hit home, do we need to restart Chrome? All right, we restarted Chrome. Check the settings. Actually, we're going to open up a new tab and hit home as well. Oh, there we go. All we had to do was restart Chrome. But once we hit the home, and we can check in the settings for appearance, we see cyborgsecurity.com. And there we go. Perfect. So now you can see how we didn't even have to go into settings for the Chrome browser, but we could do that through Registry. So once again, if a malicious actor comes in and changes registry modifications, they could change the home page or a new tab to a malicious site or a C2 site, and all information will go there, or it'll open up and infect your computer again. But once again, I cannot stress enough the power of the registry. Now that we were successful with that, let's move on to task 5. Task 5, the goal is to query the registry to find information about a specific service that is running on our computer. The service we're looking for specifically is sysmon64, and the location of services that are running can be found in System, Current Control Set, Services. So we're going to do this through PowerShell, and we're going to start with the reg query. Nope, backspace. HKLM/system/current control set, and we're going to look at services. Okay, it lists off a bunch of them, so let's scroll up real quick, see if we can confirm that it's there, and there we go in the middle of the page. So we're going to come down, and all we're going to do is add sysmon64 at the end of the registry path. Also, we're going to give it a /s, which searches recursively, so any other information that falls under there, it'll pull out. So we're going to hit go, and there we go. We have the image path for where the sysmon64 executable is, and some other information that we could research and look up. Now I'm going to verify this information in Registry Editor real quick, but the power of this command is that if an attacker gains access to your system and it starts to enumerate your machine, then they can start getting information on the services that they find, and possibly through the registry turn them off and turn them on. For example, Windows Defender. If they see that running, they can easily just kill the process or change the registry itself, and it's no longer running. So, once again, to weaken the compromised machine to make it easier to continue to infect. So if we come over to sysmon64 and we pull up the PowerShell window real quick, you can see that we had the sysmon64, which is right here. The information checks out. Also, the parameters folder, which falls under that path, that's what was captured over here, and that's what the /s helped out with. Now, to track this activity, we can check in Event Viewer, and we're going to be looking for a specific registry key event ID, which is 4656, which shows registry keys being enacted on or queried on. So we're going to let this load, but we're going to come over to Filter Current Log, and we're going to search specifically on 4656. And then we are going to find services/sysmon64. Let that search a bit. All right, it's taking its time. Maybe we need to refresh this. All right, let's do this again. Find sysmon64. Spelled it right. Yep. So this goes to show the the noisiness of the registry keys, and specifically event 4656, especially because if it's looking at every single thing being accessed, it can get quite noisy. This is just taking forever. What is happening? See if we can manually find this real quick. Wow. Wow. So if this is the case, what we can do real quick is re-execute the command, come over to refresh, run a find. Hopefully what we did was we took the event and threw it at the very top of the list. Nope. Maybe we didn't do it enough. Let's try again. All right. Whew. Took a couple times. But here it is. So the registry being audited. Here's the object name. It's actually the sysmon64 parameters one. And the process name was reg.exe. So this would be normal from an administrative point. Could be suspicious depending on who does it on a daily basis, or is there an audit going on. But if this process name was C Windows System 32 Calculator, that would be suspicious. And that's why, although these logs are very noisy, it's good to have around, especially when saying, all right, what's happening? And if we found a malicious tool that's in our environment, what is it accessing? But let's see if we can find the other sysmon64. Oh, there we go. All right, so here it hit the top level sysmon64 and stopped there. But we have officially found it. So finally, we're on to task 6. Okay, so task 6, we're going to take in a little different direction. So there are times when you're working in a lab environment, and if you don't have the resources to ship all the logs to a centralized logging solution, what you can do is there's tools out there that you can look in real time the registry keys being modified, and that's Procmon. So we're going to jump back into Procmon, and we're gonna repeat task 5, but I'm gonna show you how different it is. Yes, we're gonna overwrite those logs. We're going to stop this capture. We're going to delete it. We have everything saved, so everything's ready to hit enter. So we're going to start capturing. And if this doesn't show you the noisiness of registry keys and that it's logging, I really don't know what will. So we hit yes, and boom, all these logs are happening. So what we want to do is we're going to come over to the filter button. And we're going to first filter on the operation. So looking at operation, we're going to do a simple one, which is operation contains reg. We're going to add that to the list. Don't forget to hit add, because if you don't see it pop on or populate down here, it won't be working. We're going to hit apply. And then we're going to come over to path. And we're going to add contains current control set /services /sysmon64. Hit add, apply one more time, and hit OK. So we have nothing that's happening right now. But what we're going to do is we're going to hit enter, and all of a sudden logs populate. Because once again, we are focusing simply on the same, or the registry path that includes sysmon64. So this is 36 events, and I hit enter once. But it gives you a lot of information here that helps. But like you can see the type, which is the D word. It gives you the same information here. But if anything's changed, you'll see it within the operation itself. So a really helpful tool if you're running malware and you name it like malware2.exe, you can filter on just that executable the process name, and then you can see all the things that are happening tied to that process name itself. Now the limitations there are sometimes what malware likes to do is execute, delete itself, it executes, it creates a copy of itself with a different name somewhere else, then deletes the original version, and then if you have that filtered, you'll only be seeing the actions of the first executable. But still, Process Monitor is a very powerful tool for you to use, and you can use it in multiple ways, not just registry key modification tracking. So with that complete, all we have to do now is go on a hunt, which is personally my favorite part, because as much as I love emulating this stuff and being the attacker, I love the threat hunting portion. All right, so let's get to our sim. So here we are in the threat hunt portion of the video. We're in our sim, which is Splunk in this instance, and I've used a search query that filters only on our computer that we are using in the lab, and the events that we want to look at, which are 4656, 4657, 12, and 13. Now, for those of you that are unfamiliar with Splunk, it has the logical operators and or in, just to name a few, but I'll break down this query so that if it's confusing you, it might make some little sense. So the first, we have to declare what index of data we want to look at. So we have index sysmon or index endpoint. Now sysmon is going to contain all the event logs from the log source sysmon, and endpoint is a more generic term, but that's where we keep our Windows event logs. Our Windows event logs. We're going to skip over this part because this is just to make the query faster. I'm not really going to get into that. But then we got to focus on computer or computer name, because in these two indexes, they name the computer name differently. It would be nice if all the names were the same, but alas, it's not. But so we're desktop ST, focusing on just that computer, and the event codes, which are the event IDs. Now I use the in logical operator because what that does is that that saves me time from typing in event code equals 4656 or event code equals 4657 or 12 or 13. So what it does is the in says give me a list of things, and we're going to look at it, and then you can put the values that you're looking for in the parentheses. So we're once again 4656, 4657, 12, and 13. And this is just in the last 4 hours. So I ran the lab emulation recently, so our traffic should fall within this time frame. As you can see, there was no traffic prior to 12:18, which is when I turned this machine on. But knowing that we're just looking at 4 hours and losing about an hour, there are almost 750,000 events. So that's how noisy registry stuff is. Now, there are a couple ways that we can take this threat hunting, but I'm going to show you, we're going to start with the basics. We're going to start with event IDs from both sysmon, and then when event log, we're going to do them separately. Then we're going to start creating queries based off of registry paths and registry key names. Then we're going to search for details within the registry keys themselves. So we're going to break it down a little differently each time and kind of show how you can look for different things in different places. So let's get going. So for our first hunt, we're going to focus on sysmon event codes 12 and 13 and focus on our computer that we used in the lab. Now, I forgot to mention this, but we are going to provide you all the queries themselves within the description of the video. I will provide the Splunk query, and I will also provide a more generic query that you can use if you're not using Splunk. But I'll help you out so you don't have to pause and stop everything just to try and copy this. So that being said, Splunk has this neat way of displaying data. If we use the stats transformation command, we can pull out the values of field names that we want, and we can rename them if we wish to, which I did here to kind of help us out and break the terms into a more easily understood field. So if we take a look at our events or our results real quick, we see that there is this over here on the left. We have the image or the process or executable that is changing these. And now, if we look at these, I mean, there is a lot of registry keys just scrolling and scrolling and scrolling. I mean, it's nonstop. And you can see where there's a bunch of registry keys being monitored. So what we need to do is we need to focus on an image that we used, or that I know we used, which was reg.exe. So I'm going to refine this search and use the wildcards to do reg.exe, and that will provide us information based off of the commands that we threw when we added reg or regadd. So looking at this, we see that we did in fact use regadd to modify we added the calcpop registry key, and in the details we added the calc.exe. Now over here on the right, I took the time values and renamed them. So in case this happened more than once, you could use that to your advantage. So first we have the values with the underscore time, which is the raw time, which shows that this happened February 3rd at 2:23. The first scene was the min time, which was the same exact thing, and the max underscore time was last scene, which once again was 14:23. The reason that there's not multiple is because I did this in the lab and then we moved on. Now if there is reoccurring infections, this time will change and this time will change. But then you can determine when was this first scene, when was this last scene, and if the last scene date is the day of investigation, you can safely say that it is currently infected. So now that we have our statistics and we're looking at them, we can come over to the events and drop down and really look at the information it provides. So this is only event code 13. Now, once again, because it's reg.exe focused. But we see the target object, which is the registry path, and we see that, where are the details at? Oh, here we go. The details is the executable of the calculator. Now, if we come up here and see what happens if we do in PowerShell.exe or reg.exe, let's see if we can find the PowerShell commandlets that were thrown, or sorry, not the PowerShell commandlets, but the results from the PowerShell commandlets. So first thing you notice is we have a lot more events. We have the Splunk PowerShell, which I'm going to quickly click on, and we're going to exclude those from the results because I don't want them. And just like that, we have a bunch of registry keys over here, and PowerShell and regadd or registry executable modifying these. So this is a little messy, but what we can look at is this one at the very bottom that states software, Microsoft Windows current version, themes, personalized, apps use light theme. And if you remember, that was the registry key that we modified whenever we came to changing the all the default Windows stuff from light to dark. And then you can see there's some other registry keys being modified by PowerShell that we didn't even do. So once again, it's pretty noisy. But let's go see what Windows event logs have to provide us. For our second hunt, we're going to be focusing on the index being endpoint and the source type being our Windows event logs. Now, the reason I have source type up here is because we have multiple source types falling into our endpoint index And your environment might be like that too, and you might not know it. But a quick way to find out is if you type in index endpoint, and then you run a stats command down here, and in the values parentheses you put source type. Any source type that you're running where that falls under the index endpoint will show up as the values. So that's a quick way to learn your environment, and you could do that with any field that you want, but index and source type being, the main ones. So once again, we are filtered on event codes 4656 and 4657, the desktop being the one we used in the lab, and the process names being PowerShell or reg.exe. Now I've added a couple stats values fields because the way Windows Event Logs collects its data, it does it differently than Sysmon, and I'll show that later. But for now, I added the event code so that we can look at whether it's a 4656 or 4657. The object name, which is the registry path itself, and in Windows Event Logs, the registry path field does not contain the registry name, the registry key name. The registry key name falls under the field object value name, and any values associated with that registry key that were modified in a 4657 event will show up in the new value, and the old value, if present, will be there as well. So you can see what it was changed to, or if this is a registry key that was modified or newly created, it will have a dash in it or something signifying that nothing existed there. So let's see what results we have. We have a lot of PowerShell results, but up top here, we see 4656 and 4657 being the results. Now looking at the registry paths, we see it where it ends. If we come over to the registry key name, we have homepage location and the Cyborg security. Now if we remember, that was when we were modifying Google Chrome. So what we're going to do real quick is we're going to reroute this. We're going to remove PowerShell because it's really, really noisy. Also, we're going to come over here and add object name and object value name to the grouped by selection. And then I'm going to remove those fields in the search, because if I don't, it will send me an error. It'll tell me it doesn't like that. But now it should be a little nicer so that we can tie the registry keys up with the registry key name, the registry path, and look at the values themselves. It's just a better way of looking at it. Maybe reg.exe has a lot of results as well. This is what I get for trying to do this in real time, I guess. Oh, we got 2 results. All right, let's see what they give us. Oh, we got 4. Did I spell the fields right? We're up to 12. Let's see. All right, we have some results. So the process was reg.exe. And if we remember, this is when we added the registry key name calcpop and threw in the details section the calculator executable and its location. So knowing that, looking at the object name, we have the software Microsoft Windows current version run, which, like I said, it cuts off as the registry path, or at the end of the registry path. Then calcpop was the name that we created for the registry key. So that falls under object value name. This was a registry key modification, and the new registry data that was seen was the calculator executable and its location, and there was nothing in the old registry because this was newly created. And then you can see the times that it was created as well. So that's one way to pivot. I know it was a quick just rundown, but I wanted you to see the data, and I wanted you to understand the differences between the logs and how you can pivot. Now, if we actually look at the results here and look at the registry key names themselves. I'm sorry, did we miss all this stuff? No. Let's look for 4657. There we go. Something that we could pivot off of is the process ID, which is right here. So we're going to try this on the fly, and we're going to copy that. So a search that we can run is index equals endpoint, source type equals win event log, and we can do term, throw that in there. We're going to see what event codes that we can get. Now, what we're doing here is we're looking for the paper trail, right? So this event happened, and we have a process ID, which is a very specific ID to the process that execute this. So not only was the registry changed, or we detected in the registry being changed, we kind of found it at the end. So if we start using the process ID, we can actually work our way back to find the process that kicked it off. Now, as you can see, we have 36 events, and we have a 4656, we have a 4657, we have another event ID, which is 4663, then we have a 4688 and a 4689. I may have mentioned this at the very beginning of the video, but the 4688 and the 4689, those are process create and process terminated event IDs. So we may be able to find some information on this. So going through, actually let's jump in, let's just throw it in here to find exactly what it was. Event code equals 4688, because that term falls somewhere in one of those fields that the log had in it. And we have 2 hits. And scrolling down, let's see what happened. So we have the creator process name was PowerShell. Okay. 4688 kicked it off. Or, sorry, that was the process create event ID. The new process name is reg.exe. So parent process is creator process, and child process is new process name. So PowerShell kicked off reg.exe, and here is the process command line that was executed. So we can use the process ID to pivot off of to find the sources and the origin of the events that had happened. So like I said before, we found the registry key being edited, which was like the end of the process, and we worked our way back using the process ID. So you can use that that process ID to really chain things together and look at separate events while you're hunting and really paint a bigger picture. So that's something very useful to use as a threat hunter. Okay, with that being said, we're going to move on to our next hunt, which will be pivoting off of, or sorry, not pivoting, but we'll be searching on specific registry keys that are valuable to threat actors and what we can do to hunt them there. All right, see you there. Next on the hunt focus, we are going to look at hunting off of known registry keys and seeing the values that we get and the results that we get. So I'll be using sysmon for this one. And in the query, you see target object in current version run, current control set services, and software policies. Once again, filtering out on our machine that we use in the lab, and PowerShell and reg.exe. Now, I removed all the event time stuff because really it was making it the table really large, and I had to scroll around, and it was a little messy. So I kind of refined it just down to the details and the registry, or in the image and the target object. But I know this isn't a thrilling hunt, but if you can gather within your own environment registry keys that you and your team would prioritize based off of the threat actors that are real big actual threats to your environment. If you're in a certain sector where you have an APT that's constantly attacking other companies within your sector, you could look at their behaviors, see what registry keys they like to modify, and then add them to your list of registry keys to hunt for, and maybe in the future promote those to a detection. But this is what it would look like. We're not pivoting off of event codes, which can be used to speed up or to refine it, but really looking at target objects and details, that refines it down to a registry key log event. So if we look at it, we do have event codes just being 13, and we look at the statistics. Once again, we see our PowerShell. What did this one do? It added binary data. Not sure exactly what that was, but I don't think it was us, because I wasn't throwing any commands towards these services. But what you see is the reg.exe and the calc pop that we created using PowerShell. So if once again, if we wanted to, we could take this down, come to the the top log where we have calculator. We can get the process ID, come up to here, run a new search. Sorry, did I copy that? 8352. I can do index equals sysmon term star, copy that, and then do another stats values event code. Do that last 4 hours and run it. And once again, when you're hunting, you got to know the context behind what you're doing. And it doesn't take a lot. It just takes some research. But searching on event codes will lead you to a large amount of registry keys that you can look for and slowly weed out. Whereas this is a more advanced hunt, because we already know the context between these or behind these registry keys, and if they're modified. We're not just throwing darts in the dark. We've done our research. We've looked at, if we change or modify the registry run key, what does that mean for us? And that's why we're focusing on it. So the progression from threat hunting kind of is, your threat hunts in the beginning should cast a very, very wide net. And as you pull back data and start to look at it, you can filter through what's good, what's bad, what's malicious. And then, as you're weeding through this data, it should filter down. It should filter down because you're pulling out all the, false positives. Like, this is normal activity in my network. If that's normal, exclude it. And then once you have a list of registry keys that you've deemed suspicious or interesting, then you can take that hunt and actually make it a detection where it's alert. You get alerted on it if they are modified. Sorry for the tangent, but that's just how I roll, and that's the threat hunting maturity life cycle, I guess. And I'm just trying to help the community. All right. So off that soapbox, but looking back at this, we got index sysmon. We ran the term 8352, which was the process ID, and look at that. We got a event ID 1, which is the process create. We have event code 11. Which is actually file name being created, or a file being created. 12 and 13 are registry stuff, and 22 is a DNS query event. So I'm curious to see what that is about. But if we come to, that's event code 13. If we find the event code 1, which we can pivot off of real quick here, it should provide us command line information just like the 4688 did. We could take a look at it. Here's the process ID. The parent image is PowerShell, and the command line is query and HKLM. So this is where we actually queried the registry key itself. This one actually, so this is funny. This command line is the one where we actually added the key. This command line was an error. This should say services sysmon64. So what you didn't see me doing was practicing this off camera, and I threw that and it kept giving me an error, and I couldn't figure out why until I looked at the command line. But, I'm interested in, and this might be something that we learn, or it might just be a number attached to it. But let's see what event code 22 is giving us. Okay. So the 8352 falls within the system time. I don't think it matched on anything inside the fields except for that. Yeah, if we look at 8352. So that's just a coincidence, and that's what happens because we threw a generic term with wildcards attached to it. But that was interesting. Unexpected. While we're here, let's check out the 11. What happened there? I'm wondering if it's very similar. No, nothing? Maybe it's outside the 4-hour window. Maybe it is. Let's go bigger. Check the events. Yeah, same thing. This was the system time that it matched on and the event record ID, which at this point in the hunt, those would be false positives, and we could throw those aside. But yeah, that's our hunt based off of registry keys. I hope you learned a lot from it, and we're going to move on to the next one. Oh, and thank you for dealing with all my side tangents. That's what I do. For our next hunt, what we're going to focus on is files containing the .dll and .exe extension falling within the details of the registry, or the data field of the registry key. Now, if you remember, we created the calc_pop registry key, and we threw in the calculator's executable. So looking at the results, we see that that's in fact what we detected. Now, if you recall, the target object being the registry key path and registry key within Sysmon, you can see it here where it's Microsoft Windows current version run, but we actually added the name calc_pop and the values. Whereas as in Windows, you would see the registry path or the object name field would end at run, then object value name would be calc_pop. Sorry if I keep repeating myself, but these are the things that I constantly remind myself when I'm trying to create a query or hunt on data. I constantly have to remind myself these differences between log sources. So if you're tired of it, at least I hope you learned it. But here we are. Now, a quick note about this threat hunt. I would not use it as a detection because it's going to return a lot of false positives. Once again, I focused solely on our lab logs that we generated for this video. So that was from one computer and one specific process. Now, I ran this without the computer and image name, and there was a lot of data that returned because there's a lot of legitimate uses for this. Now, if you would find a registry key like the run key, actually is a good example of this. If you're monitoring the current version run and you run a query and there was a modification made, it could be a true positive of a threat actor dropping a malicious executable there, or it could be just administrative work, but that's still work that needs to be done and things that need to be checked out within your environment. So take it with a grain of salt. It's a good hunt to look at because you actually, even if you don't find maliciousness, this is all about learning your environment as well so that you know what's bad. And so we're going to move on to our sixth and final hunt. So for our final hunt, the goal is to find a URL falling within the new value fields within a registry key. So our query goes index endpoint, event code 4657. We're only focusing on one because if you recall, the new value field does not exist within 4656. And we're focusing on our lab computer that we used. Now, I'm using a transformation command that Splunk lets us use, and that's called rex. So any of you who are familiar or comfortable with regular expression, or regex as is commonly known, what I did here is I told Splunk to use this regular expression to look at the data within the new value field. Now, what I'm looking for, and please pardon the very basic version and explanation of this, but I'm looking for HTTP:// this vertical bar is a logical OR, so it's looking for HTTP:// or www.logical or HTTPS://. So that's the first part. And what this tells Splunk to do is to say, if you find this regular expression or this combination, find out what's after it. So once it starts here, it's got to match the second regular expression group. So what I did here was the question mark, then the brackets with URL. That's creating a new field. So whatever results I have here, I want to drop into the URL field that we created. Now, a quick explanation of this is we're looking for any lowercase, uppercase, or number combination that exists before a period, and any lowercase, uppercase, number combination that is 2 to 4 characters long. So .co, .io, .info, and basically, and I know there's a lot better versions out there, but this was my quick put together. Basically, what this is looking for is letters before a .com or .org URL type value. Now, it could return false positives, and that's where you could take that whatever it returned and make your regular expression better. But for this case, it's going to work because I made sure of it. So after all that mess, we come down here and we run a search. So this is saying, so we have to use the search because we transform some data and we don't have some terms up here. So what we're looking for is the URL field having anything in it. So a wildcard between two quotes, that's saying if values exist, I want to see the data. So what we're looking at is stats values new value, the old value, and the URL field, and we are organizing it by process name, object name, and object value name. So we have one result done by PowerShell. We look at the registry path, which is policies Google Chrome, and if you remember what we did in the lab is we modified the home page, and that's exactly what the registry key name is, home page location, and the new new value was Cyborg security. And if we look all the way over to the right, we see the URL Cyborg security. So we did successfully capture a URL within the registry key details. All right, and that is our final hunt. Okay, so this was more of an afterthought, so consider this more of a bonus section. I didn't mention it in the notes and I didn't mention it in the PowerPoint slide, but there's another tool that we can use to detect or to check our machines for auto-run locations or persistence that a malicious actor may have established. Now, this is a tool called Auto-Runs, and it's from Microsoft Sysinternals again, a great suite if you want to download it and play with it. But basically, it looks at all the locations of your computer, and it finds things that are set to boot up or kick off on boot up or restart. So looking at this, there's a bunch of tabs for different locations. When someone logs in, Explorer, Internet Explorer, but we're going to focus on the Everything section right now. Now, the first thing that we see is the HKLM software Microsoft Windows current version run registry key. So it's focusing on registry keys too. Knowing that we dropped something in there and it's not showing up, don't be alarmed, but all you have to do is come up to options and uncheck the hide Windows entries, and it gives you more visibility. Also, if you want to see other locations that things can auto run from, if you click on the hide empty locations, here we are, all the registry keys that are set to boot up or kick off applications on boot up, and you can see their values. So there's the HKCU software Microsoft Windows current version run. Now HKCU is current user, so if you would want to target a specific user, you could drop something in here and it would only kick off for them. Down here in the local machine, we see our calc pop. So it has successfully detected our auto run or our persistence that we created and established. So this is another great tool to use and to get familiar with, and I hope you enjoy it. All right, take care, everyone. Okay, I know that was a lot of information that I threw at you, and really that's information that I've gathered and learned over the course of 3 years. So I don't expect you to master it within one YouTube video. But I do want to thank you very much for your time, for sitting down and watching this. Hopefully you've learned, and if not, please hit me up. Tell me, I really want to know how well I'm teaching, because at the end of the day, I can't take the knowledge with me to the grave, and I want to make the community better. So I will provide my Twitter handle and my LinkedIn in the description. If you feel like reaching out or connecting, please do so. If you think the video needs improvement, let me know, because I really, really value your feedback, because I want to get better to make everyone else better around us. But thank you again. I hope you join us next time for the next Get to Know Your Logs video. And until then, stay safe and have fun.